somehow they're vilified. But we need people like that. We need people who enjoy that part of application of technology.
Well, people are terrified of war. So it makes sense.
Best way to avoid it has excessive military might.
Do you think that's absolutely the best way? Not diplomacy, not working stuff out?
All of it.
Yeah. You have to have military might in order to get people to sit down with you.
Right, exactly. All of it.
Otherwise, they just invade.
That's right. Why ask for permission?
Again, like you said, history. Go back and look at history. When you look at the future of AI, and you just said that no one really knows what's happening, do you ever sit down and ponder scenarios? Like, what do you think is like best case scenario for AI over the next 2 decades?
The best case scenario is that AI diffuses into everything that we do, and everything's more efficient, but the threat of war remains a threat of war. Cybersecurity remains a super difficult challenge. Somebody who's going to try to breach your security, you're going to have thousands of millions of AI agents protecting you from that threat. Your technology is going to get better. Their technology is going to get better, just like cybersecurity. Right now, while we speak, we're seeing cyber attacks all over the planet on just about every front door you can imagine. And yet, you and I are sitting here talking. And so, the reason for that is because we know that there's a whole bunch of cybersecurity technology in defense. And so we just have to keep amping that up, keep stepping that up.
This episode is brought to you by Visible. When you're a month, switch.
Not forever. Some intrusion will get in, and then we'll all learn from it. And you know, the reason why cybersecurity works is because, of course, the technology of defense is advancing very quickly. The technology of offense is advancing very quickly. However, the benefit of the cybersecurity defense is that socially, the community, all of our companies work together as one. Most people don't realize this. There's a whole community of cybersecurity experts. We exchange ideas, we exchange best practices, we exchange what we detect. The moment something has been breached, or maybe there's a loophole or whatever it is shared by everybody. The patches are shared with everybody.
That's interesting.
Yeah, most people don't realize this.
No, I had no idea. I've assumed that it would just be competitive like everything else, and they would keep secrets.
We work together, all of us.
Interesting. Yeah. Has that always been the case?
It surely has been the case for about 15 years. It might not have been the case long ago, but this.
What do you think started off that cooperation?
People recognizing it's a challenge and no company can stand alone. And the same thing is going to happen with AI. I think we all have to decide, working together to stay out of harm's way is our best chance for defense. Then it's basically everybody against the threat.
And it also seems like you'd be way better at detecting where these threats are coming from and neutralizing them.
Exactly, because the moment you detect it somewhere,
right,
you're going to find out right away.
It'll be really hard to hide.
That's right.
Yeah.
That's how it works. That's the reason why it's safe. That's why I'm sitting here right now instead of, locking everything down at NVIDIA.
It's
not only am I watching my own back, I've got everybody watching my back, and I'm watching everybody else's back.
It's a bizarre world, isn't it? When you think about that, cyber
this
threats.
idea about cybersecurity is unknown to the people who are talking about AI threats. I think when they think about AI threats and AI cybersecurity threats, they have to also think about how we deal with it today. Now, there's no question that AI is a new technology, and it's a new type of software. In the end, it's software. It's a new type of software, and so it's going to have new capabilities. But so will the defense. Where you use the same AI technology to defend against it.
So do you anticipate a time ever in the future where it's going to be impossible? Where there's not going to be any secrets? Where the bottleneck between the the technology that we have and the information that we have. Information is just all a bunch of ones and zeros. It's out there on hard drives, and the technology has more and more access to that information. Is it ever going to get to a point in time where there's no way to keep a secret?
I don't.
Because it seems like that's where everything is kind of headed in a weird
I don't
way.
think so. I think the quantum computers were supposed to.
Right.
Quantum computers will make it possible. Will make it so that the previous encryption technology is obsolete. But that's the reason why the entire industry is working on post-quantum encryption technology.
What would that look like?
New algorithms.
But the crazy thing is when you hear about the kind of computation that quantum computing can do,
Yeah.
and the power that it has,
Yeah.
where you're looking at
내가
all
그리면
the
사람이
supercomputers in
아니라
the world, it would take billions of
아니,
years,
고양이가
it takes a
아니라
few minutes to solve
사람이
these
되는
equations.
것
Like,
같아.
how do you make encryption for something that can do that?
I'm not sure, but I've got a bunch of scientists who
고양이가
are working on
고양이로
that.
나와야
I don't
되는
think you figured it out.
Yeah, we got a bunch of scientists who are experts in
사람처럼
that.
Is the
생긴
ultimate fear that it can't be breached?
어떡하지?
That quantum computing will always be able to decrypt all other quantum computing encryption? That it just gets to some point where it's like, stop playing the stupid game. We know everything.
I don't think so.
No?
Because history is a guide.
History's a guide before AI came around. That's my worry. My worry is this is totally, it's like history was one thing, and then nuclear weapons kind of changed all of our thoughts on war, and mutually assured destruction got everybody to stop using nuclear bombs.
Yeah.
My worry is that
The thing is, Joe, is that AI is not going to. It's not like.
왜 이렇게 사람같이 생겼지?
and then all
내
of a sudden one day
고양이는
AI shows up. Every single day, we're getting better and smarter because we have AI, and so we're stepping on our own AI's shoulders. So when whatever that AI threat comes, it's a click ahead. It's not a galaxy ahead. It's just a click ahead. And so I think the idea that somehow this AI is going to pop out of nowhere and somehow think in a way that we can't even imagine thinking and do something that we can't possibly imagine, I think it's far-fetched. And the reason for that is because we all have AIs, and there's a whole bunch of AIs being in development. We know what they are, and we're using it. And so every single day we're close to each other.
but don't they do things that are very surprising?
Yeah,
Don't
but
they
so
do
you have an
things
AI
that
that
are
does something
very
surprising. I'm
surprising?
going to have an AI, and
Right.
my AI looks at your AI and goes, that's not that surprising.
The fear for the layperson like myself is that AI becomes sentient and makes its own decisions, and then ultimately decides to just govern the world, do it its own way. Like, you guys, you had a good run, but
Yeah.
we're taking over now.
Yeah, but my AI is going to take care of me. I mean, so this is the cybersecurity argument.
Yes,
You
it
have an
is.
AI, and it's super smart, but my AI is super smart too, and maybe your AI. Let's pretend for a second that we understand what consciousness is, and we understand what sentience is, and that
No,
And we really are just
No.
pretending.
okay, let's just pretend for a second
Yeah.
that we believe that. I don't actually don't believe that. But nonetheless, let's pretend we believe that. So your AI is conscious and my AI is conscious, and let's say your AI is, wants to, I don't know, do something surprising. My AI is so smart that it might be surprising to me, but it probably won't be surprising to my AI. And so maybe my AI thinks it's surprising as well, but it's so smart. The moment it sees it the first time, it's not going to be surprised the second time, just like us. And so I think the idea that only one person has AI, and that one person's AI
하나,
compares everybody else's
둘,
AI as Neanderthal is probably unlikely. I think it's much more like cybersecurity.
Interesting. I think the fear is not that your AI is going to battle with somebody else's AI. The fear is that AI is no longer going to listen to you. That's the fear, is that human beings won't have control over it after a certain point. If it achieves sentience and then has the ability to be autonomous.
That there's one AI.
Well, they just combine.
Yeah, becomes one
That
AI.
it's a life form.
Yeah.
But there's arguments about that, right? That we're dealing with some sort of synthetic biology, that it's not as simple as new technology, that you're creating a life form.
If it's like life form, let's go along with that for a while. I think if it's like life form, as you know, all life forms don't agree. And so I'm going to have to go with your life form and my life form. I'm going to agree because my life form is going to want to be the super life form. And now that we have disagreeing life forms, we're back again to where we are.
Well, they would probably cooperate with each other. It would just... The reason why we don't cooperate with each other is we're territorial primates. But AI wouldn't be a territorial primate. It would realize the folly in that sort of thinking, and it would say, listen, there's plenty of energy for everybody. We don't need to dominate. We're not trying to acquire resources and take over the world. We're not looking to find a good breeding partner. We're just existing as a new super life form that these cute monkeys created for us.
Okay, well, that would be a superpower with no ego.
Right.
And if it has no ego, why would it have the ego to do any harm to us?
Well, I don't assume that it would do harm to us, but the fear would be that we would no longer have control, and that we would no longer be the apex species on the planet. This thing that we created would now be. Is that funny?
No. I just think
Scary.
it's not going to happen.
I know you think it's not going to happen, but it could, right? And
could,
here's the
yeah.
other thing: is like if we're racing towards could, and could be the end of human beings being in control of our own destiny.
I just think it's extremely unlikely.
That's what they said in the Terminator movie.
And it hasn't happened.
No, not yet, but you guys are working towards it. The thing about you're saying about conscience and sentience, that you don't think that AI will achieve consciousness, or that
The question is,
consciousness
what's the
specific?
definition? Yeah,
Right.
what's the definition? of
What is the
consciousness?
definition to you?
Consciousness. I guess first of all, you need to know about your own existence.
어디 보자. 날씨가
You have to have experience, not just knowledge and intelligence.
저녁에 비 온다고?
The concept of a machine having an experience, well, first of all, I don't know what defines experience, why we have experiences, and,
Right.
and why this microphone doesn't. And so I think I know,
오늘도
I
비
think
오고 내일도 비
I
오고
know what consciousness is. The sense of experience, the ability to know self versus the ability to be able to reflect, know our own self, the sense of ego. I think
아이고
all of those human experiences
눈 그리는 게 왜 이렇게
probably
어렵지?
is what consciousness is.
고양이 눈 너무 어려워.
Why it exists versus the concept of knowledge and intelligence, which is what AI is defined by today.
Mm-hmm.
It has knowledge, it has intelligence. Artificial intelligence, we don't call it artificial consciousness. Artificial intelligence, the ability to perceive, recognize, understand, plan, perform tasks. Those things are foundations of intelligence. To know things, knowledge. It's clearly different than consciousness.
But consciousness is so loosely defined. How can we say that? I mean, doesn't a dog have consciousness?
Yeah,
Dogs seem to be pretty conscious.
that's right.
Yeah. So, and that's a lower level consciousness than a human being's consciousness.
I'm not sure. Yeah, right.
Well,
The question is what lower
not
level
even lower
intelligence.
level,
It's
yeah.
lower level intelligence.
Yes.
But I don't know that's lower level consciousness.
That's a good point.
Yeah.
Right.
Because
Good
I
point.
believe my dogs feel as much as I feel.
Yeah, they feel a lot.
Yeah, right.
Yeah, they get attached to you.
That's
They-
right.
They get depressed if you're not
That's
there.
right.
Yeah.
Exactly.
There's definitely that.
Yeah.
The concept of experience. But isn't AI interacting with society? So doesn't it acquire experience through that interaction?
I don't think interaction is experience. I think experience is a collection of feelings, I think.
You're aware of that AI, I forget which one, where they gave it some false information about one of the programmers having an affair with his wife just to see how it would respond to it. And then when they said they were going to shut it down, it threatened to blackmail him and reveal his affair. And it was like, whoa, like it's conniving. Like if that's not learning from experience and being aware that you're about to be shut down, which would imply at least some kind of consciousness, or you could kind of define it as consciousness if you were very loose with the term. And if you imagine that this is going to exponentially become more powerful, wouldn't that ultimately lead to a different kind of consciousness than we're defining from biology?
Well, first of all, let's.
Emmy Award-winning Derek Huff's Symphony of Dance returns with Encore, a brand new live show taking you on a journey through a true fusion of dance and music. Experience
True fusion of dance and music.
cast of dancers and a one-of-a-kind stunning stage show production.
One of a kind stage production.
Encore, live at Casino Rama Resort, Saturday, July 4th.
Saturday, July 4th.
.ca. For more, visit derekhuff.com.
Dun, 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 dun. Da-dum, dum, dum, da-dum, dum, dum, da-dum, dum. Dum, 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 dum.
Let's just break down what it probably did. It probably read somewhere. There's probably text that in these consequences, certain people did that. You know, I
Right.
could imagine a novel
Right.
having those words related.
Sure.
And so inside,
it realizes its strategy for survival
it's
is
just a bunch of numbers.
blackmail.
It's just a bunch of numbers that in the collection of numbers that relates to a husband cheating on a wife, has subsequently a bunch of numbers that relates to blackmail and such things. However, whatever the revenge was,
Right.
and so it has spewed it out. And so it's just like, you know, it's just as if I'm asking it to write me a poem in Shakespeare. It's just whatever the words are in the word in that dimensionality. This dimensionality is all these vectors in multi-dimensional space. These words that were in the prompt that described the affair subsequently led to one word after another, led to some revenge and something. But it's not because it had consciousness or it just spewed out those words, generated those words.
I understand what you're saying.
Yeah.
That
It's
it
not-
learned
it's
from
not a
patterns that human
Right.
beings have exhibited both in
That's
literature
right.
and in real life.
That's exactly right.
But at a certain point in time, one would say, okay, well, it couldn't do this 2 years ago, and it couldn't do this 4 years ago. Like, when we were looking towards the future, like, at what point in time when it can do everything a person does, what point in time do we decide that it's conscious? If it absolutely mimics all human thinking and behavior patterns,
That doesn't make it conscious.
it becomes indiscernible. It's aware. It can communicate with you the exact same way a person can. Like, is consciousness? Like, are we putting too much weight on that concept? Because it seems like it's a version of a kind of consciousness,
It's a version of imitation.
imitation consciousness, right? But if it perfectly imitates it,
I still think it's an example of imitation.
so it's like a fake Rolex when they 3D print them and make them look indiscernible.
The question is, what's the definition of consciousness?
Yeah. That's the question, and I don't think anybody's really clearly defined that. That's where it gets weird, and that's where the real doomsday people are worried that you are creating a form of consciousness that you can't control.
I believe it is possible to create a machine that imitates human intelligence and has the ability to understand information, understand instructions, break the problem down, solve problems, and perform tasks. I believe that completely. I believe that we could have some of it generated by humans, some of it generated synthetically, and more of knowledge in the world will be generated synthetically going forward. You know, until now, the knowledge that we have are knowledge that we generate and we propagate and we send to each other and we amplify it and we add to it and we modify it, we change it. In the future, in a couple of years, maybe 2 or 3 years, 90% of the world's knowledge will likely be generated by AI.
That's crazy.
I know, but it's just fine.
But it's just fun.
I
But
know.
it's just
And
fine.
the reason for that is this. Let me tell you why.
Okay.
It's because what difference does it make to me that I'm learning from a textbook that was generated by a bunch of people I didn't know, or written by a book that, you know, from somebody I don't know, to knowledge generated by AI computers that are assimilating all of these and resynthesizing things. To me, I don't think there's a whole lot of difference. We still have to fact check it. We still have to make sure that it's, you know, based on fundamental first principles, and we still have to do all of that just like we do today.
Is this taking into account the kind of AI that exists currently? And do you anticipate that, just like we could have never really believed that AI would be, at least a person like myself, would never believe AI would be as so ubiquitous and so worth it's so powerful today and so important today. You never thought that 10 years ago. Never thought that.
Right.
You imagine, like, what are we looking at 10 years from now?
I think that if you reflect back 10 years from now, you would say the same thing, that we would have never believed that. But
In a different direction.
right. But if you go forward 9 years from now, and then ask yourself what's going to happen 10 years from now, I think it'll be quite gradual.
One of the things that Elon said that makes me happy is he believes that we're going to get to a point where it's not necessary for people to work, and not meaning that you're going to have no purpose in life, but you'll have, in his words, universal high income, because so much revenue is generated by AI that it will take away this need for people to do things that they don't really enjoy doing just for money. And I think a lot of people have a problem with that because their entire identity and how they think of themselves and how they fit in the community is what they do. Like, this is Mike, he's an amazing mechanic, go to Mike, and Mike takes care of things. But there's going to come a point in time where AI is going to be able to do all those things much better than people do. And people will just be able to receive money. But then what does Mike do? Mike is, really loves being the best mechanic around. What does the guy who, codes, what does he do when AI can code infinitely faster with 0 errors? Like, what happens with all those people? And that is where it gets weird. It's like, because we've sort of wrapped our identity as human beings around what we do for a living. When you meet someone, one of the first things you meet somebody at a party, hi, Joe, what's your name? Mike, what do you do, Mike? And, Mike's like, oh, I'm a lawyer. Oh, what kind of law? And you have a conversation, When Mike's like, I get money from the government, I play video games. It gets weird. And I think the concept sounds great until you take into account human nature. And human nature is that we like to have puzzles to solve, things to do, and an identity that's wrapped around our idea that we're very good at this thing that we do for a living.
Yeah, I think, let's see. Let me start with the more mundane, and I'll work backwards.
Okay.
So, one of the predictions from Jeff Hinton, who started the whole deep learning phenomenon, deep learning technology trend, and incredible researcher, professor at University of Toronto. He discovered or invented the idea of backpropagation, which allows the neural network to learn. And as you know, for the audience, software historically was humans applying first principles in our thinking to describe an case of deep learning, this invention of artificial intelligence, we put a structure of a whole bunch of neural networks and a whole bunch of math units. And we make this large structure. It's like a switchboard of little mathematical units. And we connect it all together. And we give it the input that the software would eventually receive. And we just let it randomly guess what the output is. And so we say, for example, the input could be a picture of a cat. And one of the outputs of the switchboard is where the cat signal is supposed to show up. And all of the other signals, the other one's a dog, the other one's an elephant, the other one's a tiger, and all of the other signals are supposed to be 0 when I show it a cat. And the one that is a cat should be 1. And I show it a cat through this big, huge network of switchboards and math units. And they're just doing multiply and adds, multiplies and adds, okay? And this thing, this switchboard is gigantic. The more information you're going to give it, the bigger this switchboard has to be. And what Jeff Hinton discovered was a way for you to guess that, put the cat signal in, put the cat image in, and that cat image, could be a million numbers, because it's, a megapixel image, for example. And it's just a whole bunch of numbers, and somehow from those numbers, it has to light up the cat signal. Okay, that's the bottom line. And if the first time you do it, it just comes up with garbage. And so it says the right answer is cat. And so you need to increase this signal and decrease all of the other, and back propagates the outcome through the entire network. And then you show it another, now it's an image of a dog. And it guesses it, takes a swing at it, and it comes up with a bunch of garbage. And you say, no. The answer is this is a dog. I want you to produce dog. And all the other other outputs have to be 0. And I want to back propagate that and just do it over and over and over again. It's just like showing
over
a
and
kid,
over
this is
and
an apple,
over
this is a dog, this is a
again.
cat. And you just keep showing it to
Over
them
and
until
over and
they eventually
over
get it.
again.
Okay, well anyways, that big invention is deep learning. That's the foundation of artificial intelligence. A piece of software that learns from examples. That's basically machine learning. A machine that learns.
Machine learning.
And so one of the big first applications was image recognition. And one of the most important image recognition applications is radiology. And so he predicted about 5 years ago that in 5 years' time, the world won't need any radiologists because AI would have swept the whole field. Well, it turns out AI has swept the whole field. That is completely true. Today, just about every radiologist is using AI in some way. And what's ironic, though, what's interesting is that the number of radiologists has actually grown. And so the question is why? That's kind of interesting, right?
It is.
And so the prediction was, in fact, that 30 million radiologists will be wiped out. But as it turns out, we needed more. And the reason for that is because the purpose of a radiologist is to diagnose disease, not to study the image. The image studying is simply a task in service of diagnosing the disease. And so now, the fact that you could study the images more quickly and more precisely without ever making a mistake and never gets tired. You could study more images. You could study it in 3D form instead of 2D because, the AI doesn't care whether it studies images in 3D or 2D. You could study it in 4D. And so now you could study images in a way that radiologists can't easily do. And you could study a lot more of it And so the number of tests that people are able to do increases. And because they're able to serve more patients, the hospital does better. They have more clients, more patients. As a result, they have better economics. When they have better economics, they hire more radiologists because their purpose is not to study the images. Their purpose is to diagnose disease. And so the question is, what I'm leading up to is, ultimately, what is the purpose? What is the purpose of the lawyer? And has the purpose changed? What is the purpose? You know, one of the examples that I gave that I would give is, for example, if my car became self-driving, will all chauffeurs be out of jobs? The answer probably is not. Because for some chauffeurs, for some people who are driving you, they could be protectors. Some people, they're part of the experience, part of the service. So when you get there, they can take care of things for you. And so for a lot of different reasons, not all chauffeurs would lose their jobs. Some chauffeurs would lose their jobs. And many chauffeurs would change their jobs. And the type of applications of autonomous vehicles will probably increase. You know, the usage of the technology would then find new homes. And so I think you have to go back to, what is the purpose of a job? You know, like for example, if AI comes along, I actually don't believe I'm going to lose my job because my purpose isn't to, I have to look at a lot of documents, I study a lot of emails, and look at a bunch of diagrams, you know. The question is, what is the job? And the purpose of somebody probably hasn't changed. A lawyer, for example, help people. That probably hasn't changed. Studying legal documents, generating documents is part of the job, not the job.
But don't you think there's many jobs that AI will replace?
If your job
Particularly
is
automation.
the task. Yeah, if your job is the task.
Right. So automation.
Yeah.
Factory
If your job,
workers.
If your job is the task.
That's a lot of people.
It could be a lot of people, but it'll
Yeah.
probably generate, like for example, let's say I'm super excited about the robots Elon's working on. It's still a few years away. When it happens, there's a whole new industry of technicians and people who have to manufacture the robots, right?
Mm-hmm.
And so that job never existed. And so you're going to have a whole industry of people taking care of, like for example, you know, all the mechanics and all the people who are building things for cars, supercharging cars. That didn't exist before cars, and now we're going to have robots. You're going to have robot apparels. So a whole industry of, right? Isn't that right? Because I want my robot to look different than your robot. And so you're gonna have a whole, you know, apparel industry for robots. You're gonna have mechanics for robots, and you have, you know, people who come to maintain your robots.
Automated, though?
No,
You don't think so? You don't
No,
think that'll
not
be all
all of
done
it.
by other robots?
eventually, and then there'll be something else.
So
Yeah.
you think ultimately people just adapt, except if you are the task,
That's
which
right.
is a large percentage of the workforce.
If your job is just to chop vegetables, Cuisinart's going to replace you.
Yeah. So people have to find meaning in other things.
Your job has to be more than the task.
What do you think about Elon's belief that this universal basic income thing will eventually become necessary? Many people think that. Andrew Yang thinks
Yeah.
that. So, he was one of the first people to sort of sound that alarm during the 2020 election.
Yeah, I guess yeah, both ideas probably won't exist at the same time, and as in life, things will probably be in the middle. One idea, of course, is that there'll be so much abundance of resource that nobody needs a job, and we'll all be wealthy. On the other hand, we're going to need universal basic income. Both ideas don't exist at the same time.
Right.
And so we're either going to be all wealthy, or we're going to be all.
How could everybody be wealthy though?
Well, because
scenario.
wealthy, not because you have a lot of dollars. Wealthy because there's a lot of abundance. Like for example, today, we are wealthy of information. You know, this is a concept several thousand years ago. Only a few people have, and so today we have wealth of a whole bunch of things, resources that
That's a good
historic.
point.
Yeah.
Yeah.
And so we're going to have wealth of resources, things that we think are valuable today. that in the future are just not that valuable, you know, and so because it's automated. And so I think the question maybe partly it's hard to answer, partly because it's hard to talk about infinity, and it's hard to talk about a long time from now. And the reason for that is because there's just too many scenarios to consider. But I think in the next several years, call it 5 to 10 years, there's several things that I believe in hope. And I say hope because I'm not sure. One of the things that I believe is that the technology divide will be substantially collapsed. And of course, the alternative viewpoint is that AI is going to increase the technology divide. Now, the reason why I believe AI is going to reduce the technology divide is because we have proof. The evidence is that AI is the easiest application in the world to use. ChatGPT has grown to almost 1 billion users, frankly, practically overnight. And if you're not exactly sure how to use, everybody knows how to use ChatGPT, just say something to it. If you're not sure how to use ChatGPT, you ask ChatGPT how to use it. No tool in history has ever had this capability. A Cuisinart, you know, if you don't know how to use it, you're kind of screwed. You're gonna walk up to it and say, how do you use a Cuisinart? You're gonna have to find somebody else. And so, but an AI will just tell you exactly how to do it. Anybody could do this. It'll speak to you in any language. And if it doesn't know your language, you'll speak it in that language, and it'll probably figure out that it doesn't completely understand your language, go and learns it instantly, and comes back to talk to you. And so I think the technology divide has a real chance finally that you don't have to speak Python or C++ or Fortran. You can just speak human in whatever form of human you like. And so I think that has a real chance of closing the technology divide. Now, of course, the counter narrative would say that AI is only going to be available for the nations and the countries that have a vast amount of resources, because AI takes energy and AI takes a lot of GPUs and factories to be able to produce the AI. No doubt at the scale that we would like to do in the United States. But the fact of the matter is, your phone's going to run AI just fine, all by itself, you know, in a few years. Today, it already does it fairly decently. And so, the fact that every country, every nation, every society will have the benefit of very good AI. It might not be tomorrow's AI. It might be yesterday's AI. But yesterday's AI is freaking amazing. You know, in 10 years' time, 9-year-old AI is going to be amazing. You don't need 10-year-old AI. You don't need frontier AI like we need frontier AI, because we want to be the world leader. But for every single country, everybody, I think the capability to elevate everybody's knowledge and capability and intelligence, that day is coming.
The Octagon isn't just in Las Vegas anymore.
York, this may apply in
Real bottleneck when it comes to third world countries and
That's right.
electricity and all the resources that we take for granted.
Almost everything is going to be energy constrained. And so if you take a look at one of the most important technology advances in history is this idea called Moore's Law. Moore's Law started basically in my generation. And my generation is the generation of computers. I graduated in 1984, and that was basically at the very beginning of the PC revolution and the microprocessor. And every single year, it approximately doubled. And we describe it as every single year we double the performance. But what it really means is that every single year, the cost of computing halved. And so the cost of computing in the course of 5 years reduced by a factor of 10. The amount of energy necessary to do computing, to do any task, reduced by a factor of 10. Every single 10 years, 100, 1,000, 10,000, 100,000, so on and so forth. And so each one of the clicks of Moore's law, the amount of energy necessary to do any computing reduced. That's the reason why you have a laptop today. When back in 1984, it sat on the desk, you got to plug in. It wasn't that fast, and it consumed a lot of power. Today, it is only a few watts. And so Moore's law is the fundamental technology trend that made it possible. Well, what's going on in AI? The reason why NVIDIA's here is because we invented this new way of doing computing. We call it accelerated computing. We started it 33 years ago. It took us about 30 years to really made a huge breakthrough. In that 30 years or so, we took computing, probably a factor of, well, let me just say like last 10 years. The last 10 years, we improved the performance of computing by 100,000 times. Imagine a car over the course of 10 years that became 100,000 times faster. Or at the same speed, 100,000 times cheaper. Or at the same speed, 100,000 times less energy. If your car did that, it doesn't need energy at all. What I mean, what I'm trying to say is that in 10 years' time, the amount of energy necessary for artificial intelligence for most people will be minuscule. Utterly minuscule. And so we'll have AI running on all kinds of things and all the time because it doesn't consume that much energy. And so if you're a nation that uses AI for, almost everything in your social fabric, of course you're going to need these AI factories. But for a lot of countries, I think you're going to have excellent AI, and you're not going to need as much energy. Everybody will be able to come along. That's my point.
So currently, that is a big bottleneck, right? It's energy.
Yeah. It is the bottleneck.
The bottleneck.
Yeah.
Is this so? Was it Google that is making nuclear power plants to operate one of its AI factories?
Oh, I haven't heard that, but I think in the next 6-7 years, I think you're going to see a whole bunch of small nuclear reactors.
And by small, like how big are you talking about?
Hundreds of megawatts, yeah.
Okay. And that these will be local to
That's
whatever
right.
specific company they have?
That's right. We'll all be power generators.
Whoa.
Just like your, somebody's farm.
It probably is the smartest way to do it, right?
And it
Certainly
takes the burden off.
cleanest.
Yeah, it takes the burden off the grid. It takes.
Yeah.
And you can build as much as you need. And you can contribute back to the grid.
It's a really important point that I think you just made about Moore's law and the relationship to pricing. Because, a laptop today, like you can get one of those little MacBook Airs, they're incredible. They're
It's
so
incredible.
thin, unbelievably powerful, battery
You don't
life is
ever have to
crazy.
charge it.
Yeah, battery life is crazy. And it's not that expensive,
That's
relatively speaking. It's something like that. I remember
And that's just Moore's law.
Right.
Then there's the NVIDIA law.
Oh,
Just, right? The
Yeah.
law I was talking to you about.
Yeah.
The computing that we
Right.
invented.
right.
The reason why we're here, this new way of doing computing, is like Moore's law on energy drinks. I mean, it's it's like Moore's law. it's like Moore's law on Joe Rogan.
Wow, that's interesting.
Yeah, that's us.
So explain that. This chip that you brought to Elon.
Yeah.
What's the significance of this? Like, why is it so superior?
And so, in 2012, Jeff Hinton's lab, this gentleman I was talking about, Ilya Sutskever, Alex Krzyzewski, they made a breakthrough in computer vision, in literally creating a piece of software called AlexNet, and its job was to recognize images, and it recognized images at a level computer vision, which is fundamental to intelligence. If you can't perceive, it's hard to have intelligence. And so computer vision is a fundamental pillar of, not the only, but fundamental pillar of. And so breaking computer vision, or breaking through in computer vision, is pretty foundational to almost everything that everybody wants to do in AI. And so in 2012, their lab in Toronto made this breakthrough called AlexNet, and AlexNet was able to recognize images so much better than any human created computer vision algorithm in the 30 years prior. So all of these people, all these scientists, and we had many too, working on computer vision algorithms. And these two kids, Ilya and Alex, under Jeff Hinton, took a giant leap above it. And it was based on this thing called AlexNet, this neural network. And the way it ran, the way they made it work was literally buying 2 NVIDIA graphics cards. Because NVIDIA's GPUs, we've been working on this new way of doing computing. And our GPU's application, and it's basically a supercomputing application back in 1984, in order to process computer games and what you have in your racing simulator, that is called an image generator supercomputer. And so NVIDIA started, our first application was computer graphics. And we applied this new way of doing computing where we do things in parallel instead of sequentially. A CPU does things sequentially. Step 1, step 2, step 3. In our case, we break the problem down and we give it to thousands of processors. And so our way of doing computation is much more complicated, but if you're able to formulate the problem in the way that we created called CUDA, this is the invention of our company, if you could formulate it in that way, we could process everything simultaneously. Now in the case of computer graphics, it's easier to do because every single pixel on your screen is not related to every other pixel. And so I could render multiple parts of the screen at the same time. Not completely true, because maybe the way lighting works or the way shadow works, there's a lot of dependency and such. But
다하
computer
안녕하세요.
graphics with all the pixels, I should be able to process everything simultaneously. And so we took this embarrassingly parallel problem called computer graphics and we applied it to this new way of doing computing, NVIDIA's accelerated computing. We put it in all of our graphics cards. Kids were buying it to play games. You probably don't know this, but we're the largest gaming platform in the world today.
Oh, I know that.
Oh, okay.
I used to make my own computers. I used to buy your graphics cards.
Oh, that's super cool.
Yeah.
Okay.
Set up SLI with 2 graphics
yep.
cards. Hey, Canada, the holidays are in 3 rounds of the Q.
Yeah, I love it.
Yeah.
Okay, that's super cool.
Oh yeah, man, I used to be a Quake junkie.
Oh, that's cool.
Yeah.
Okay, so SLI, I'll tell you the story in just a second, and how it led to Elon. I'm still answering the question. And so, anyways, these 2 kids trained this model
이게
using
뭐예요?
the technique I described earlier on our GPUs because our GPUs could process things in parallel. It's essentially a supercomputer in a PC. The reason why you used it for Quake is because it is the first consumer supercomputer. Okay, and so anyways, they made that breakthrough. We were working on computer vision at the time. It caught my attention. And so we went to learn about it. Simultaneously, this deep learning phenomenon was happening all over the country. Universities after another recognized the importance of deep learning, and all of this work was happening at Stanford, at Harvard, at Berkeley, just all over the place. New York University, Jan LeCun, Andrew Yang at Stanford, so many different places. And I see it cropping up everywhere. And so my curiosity asked, what is so special about this form of machine learning? And we've known about machine learning for a very long time. We've known about AI for a very long time. We've known about neural networks for a very long time. What makes now the moment? And so we realized that this architecture for deep neural networks, backpropagation, the way deep neural networks were created, we could probably scale this problem, scale the solution to solve many problems. That is essentially a universal function approximator. Okay, meaning, back when you're in school, you have a box. Inside of it is a function. You give it an input, it gives you an output. And the reason why I call it a universal function approximator is that this computer instead of you describing the function, a function could be a Newton's equation, F equals ma. That's a function. You write the function in software, you give it input F, mass, acceleration, it'll tell you the force. Okay? And the way this computer works is really interesting. You give it a universal function. It's not F equals ma, just a universal function. It's a big, huge, deep neural network. And instead of describing the inside, you give it examples of input and output, and it figures out the inside. So you give it input and output, and it figures out the inside. A universal function approximator. Today, it could be Newton's equation. Tomorrow, it could be Maxwell's equation. It could be Coulomb's law. It could be the thermodynamics equation. It could be, Schrodinger's equation for quantum physics. And so you could have this describe almost anything, so long as you have the input and the output. So long as you have the input and the output. Or it could learn the input and output. And so we took a step back and we said, hang on a second. This isn't just for computer vision. Deep learning could solve any problem. All the problems that are interesting, so long as we have input and output. Now, what has input and output? Well, the world. The world has input and output. And so we could have a computer that could learn almost anything. Machine learning, artificial intelligence. And so we reasoned that maybe this is the fundamental breakthrough that we needed. There were a couple of things that had to be solved. For example, we had to believe that you could actually scale this up to giant systems. It was running they had two graphics cards, two GTX 580s, which, by the way, is exactly your SLI configuration.
Yeah.
Okay, so that GTX 580 SLI was the revolutionary computer that put deep learning on the map.
Wow.
It was 2018, and you were using it to play Quick.
Wow. That's crazy.
That was the moment. That was the big bang of modern AI. We were lucky because we were inventing this technology, this computing approach. We were lucky that they found it. Turns out they were gamers, and it was lucky they found it. And it was lucky that we paid attention to that moment. It was a little bit like, that Star Trek, First Contact. The Vulcans had to have seen the warp drive at that very moment. If they didn't witness the warp drive, they would have never come to Earth, and everything would have never happened. It's a little bit like if I hadn't paid attention to that moment, that flash, and that flash didn't last long. If I hadn't paid attention to that flash, or our company didn't pay attention to it, who knows what would happen? But we saw that, and we reasoned our way into this is a universal function approximator. This is not just a computer vision approximator. We could use this for all kinds of things if we could solve two problems. The first problem is that we have to prove to ourselves it can scale. The second problem we had to wait for, contribute to and wait for, is the world will never have enough data on input and output where we could supervise the AI to learn everything. For example, if we have to supervise our children on everything they learn, the amount of information they can learn is limited. We needed the AI, we needed the computer to have a method of learning without supervision. And that's where we had to wait a few more years, but unsupervised AI learning is now here. And so the AI could learn by itself. And the reason why the AI could learn by itself is because we have many examples of right answers. Like, for example, if I want to learn, if I want to teach an AI how to predict the next word, I could just grab a whole bunch of text that we already have, mask out the last word, and make it try again until it predicts the next one. Or I mask out random words inside the text, and I make it try until it predicts it. Mary goes down to the bank. Is it a river bank or a money bank? Well, if you're going to go down to the bank, it's probably a river bank. Okay, so, and it might not be obvious even from that. It might need and caught a fish. Okay, now you know it must be the riverbank. And so you give these AIs a whole bunch of these examples, and you mask out the words. It'll predict the next one. Okay, and so unsupervised learning came along. These two ideas, the fact that it's scalable and unsupervised learning came along, we were convinced that we had to put everything into this and help create this industry because we're going to solve a whole bunch of interesting problems. And that was in 2012. By 2016, I had built this computer called the DGX-1. The one that you saw me give to Elon is called DGX Spark. The DGX-1 was $300,000. It cost NVIDIA a few $1 billion to make the first one. And instead of 2 chips SLI, we connected 8 chips with a technology called NVLink. But it's basically SLI supercharged. Okay? And so we connected 8 of these chips together instead of just 2. And all of them work together, just like your Quake rig did, to solve this deep learning problem, to train this model. And so we created this thing. I announced it at GTC and at one of our annual events. And I described this deep learning thing, computer vision thing, and this computer called DGX-1. The audience was like completely silent. They had no idea what I was talking about. And I was lucky because I'd known Elon, and I helped him build the first computer for Model 3, the Model S. And when he wanted to start working on autonomous vehicle, I helped him build the computer that went into the Model S AV system, his full self-driving system. We were basically the FSD computer version 1. And so we're already working together. And when I announced this thing, nobody in the world wanted it. I had no purchase orders, not one, nobody. Exactly the same industrial design.
He's holding it in his hand.
다시 왔습니다. 잠깐만요.
Here's the amazing thing. DGX-1 was 1 petaflops. Okay, that's a lot of flops. And DGX Spark is 1 petaflops. 9 years later.
Wow.
The same amount of computing horsepower
In a much smaller.
shrunken down.
Yeah.
And instead of $300,000, it's now $4,000.
And it's the size of a small book. crazy.
That's
Yeah.
how technology moves. Anyways, that's the reason why I wanted to give him the first one.
It's so
Because I gave him the first one in 2016.
it's so fascinating. I mean, if you wanted to make a story for a film, I mean, that would be the story. That like, what better scenario if it really does become a digital life form? How funny would it be that it is birthed out of the desire for computer graphics for video games?
Exactly.
Isn't it kind of crazy? It's kind of crazy.
Yeah.
Kind of crazy when you think about it that way, because I mean,
Well, it turns
perfect
out
origin story.
computer graphics was one of the hardest supercomputer problems. Generating reality.
And
is hard.
also one of the most profitable to solve, because computer games are so popular.
When NVIDIA started in 1993, we were trying to create this new computing approach. The question is, what's the killer app? And the problem we wanted to, the company wanted to create a new type of computing computing architecture, a new type of computer that can solve problems that normal computers can't solve. Well, the applications that existed in the industry in 1993 are applications that normal computers can solve, because if the normal computers can't solve them, why would the application exist? And so we had a mission statement for a company that has no chance of success. But I didn't know that in 1993. It just sounded like a good idea.
Right.
And so if we created this thing that can solve problems, it's like you actually have to go create the problem. And so that's what we did. In 1993, there was no Quake. John Carmack hadn't even released Doom yet. You probably remember that.
Sure. Yeah.
Sure.
And there were no applications for it. And so I went to Japan, because the arcade industry had this, at the time of Sega, if you remember.
Sure.
The arcade machines, they came out with 3D arcade systems. Virtual Fighter, Daytona, Virtual Cop. All of those arcade games were in 3D for the very first time. And the technology they were using was from Martin Marietta. The flight simulators, they took the guts out of a flight simulator and put it into an arcade machine. The system that you have over here, it's got to be 1,000,000 times more powerful than that arcade machine. And that was a flight simulator for NASA.
Whoa.
And so they took the guts out of that. They were using it for flight simulation for jets and space shuttle, and they took the guts out of that. And Sega had this brilliant computer developer. His name was Yu Suzuki. Yu Suzuki and Miyamoto, Sega and Nintendo. These were the incredible pioneers, the visionaries, the incredible artists, and they're both very, very technical. They were the origins, really, of the gaming industry. And Yu Suzuki pioneered 3D graphics gaming. And so we created this company, and there were no apps. And we were spending all of our afternoons, we told our family we were going to work, but it was just the three of us, who's going to know. And so we went to Curtis's, one of the founders, went to Curtis's townhouse. And Chris and I were married, we have kids. I already had Spencer and Madison. They were probably 2 years old. And Chris's kids are about the same age as ours. And we would go to work in this townhouse. But, when you're a startup, and the mission statement is the way we described, you're not going to have too many customers calling you. And so we had really nothing to do. And so after lunch, we would always have a great lunch. After lunch, we would go to the arcades and play the Sega Virtual Fighter and Daytona and all those games, and analyze how they're doing it, try to figure out how they were doing that. And so we decided, let's just go to Japan. Let's convince Sega to move those applications into the PC. would start the PC gaming, the 3D gaming industry, partnering with Sega. That's how NVIDIA started.
Wow.
And so in exchange for them developing their games for our computers in the PC, we would build a chip for their game console. That was the partnership. I build a chip for your game console, you port the Sega games to us, and then they paid us at the time quite a significant amount of money to build that game console. And that was kind of the beginning of NVIDIA getting started, and we thought we were on our way. And so I started with a business plan, a mission statement that was impossible. We lucked into the Sega partnership. We started taking off, started building our game console. And about a couple years into it, we discovered our first technology didn't work. It would have been a flaw. It was a flaw. And all of the technology ideas that we had, the architecture concepts were sound, but the way we were doing computer graphics was exactly backwards. Instead of, I won't bore you with the technology, but instead of inverse texture mapping, we were doing forward texture mapping. Instead of triangles, we did curved surfaces. So other people did it flat, we did it round. Other technology, the technology that ultimately won, the technology we use today, has Z buffers. It automatically sorted. We had an architecture with no Z buffers. The application had to sort it. So we chose a bunch of technology approaches that three major technology choices, all three choices were wrong. Okay, so this is how incredibly smart we were. And so, in 1995, mid-95, we realized we were going down the wrong path. Meanwhile, the Silicon Valley was packed with 3D graphic startups because it was the most exciting technology at that time. And so 3D FX and rendition and Silicon Graphics was coming in. Intel was already in there. And, what added up eventually to 100 different startups we had to compete against. Everybody had chosen the right technology approach, and we chose the wrong one. And so we were the first company to start. We found ourselves essentially dead last with the wrong answer. And so the company was in trouble. And ultimately we had to make several decisions. The first decision is, well, if we change now, we will be the last company. And even if we changed into the technology that we believed to be right, we'd still be dead. And so that argument, do we change and therefore be dead? Don't change and make this technology work somehow? Or go do something completely different? That question stirred the company strategically and was a hard question. I eventually, advocated for, we don't know what the right strategy is, but we know what the wrong technology is. So let's stop doing it the wrong way, and let's give ourselves a chance to go figure out what the strategy is. The second problem we had was our company was running out of money, and I was in a contract with Sega, and I owed them this game console. And if that contract would have been canceled, we'd be dead. We would have vaporized instantly. And so I went to Japan and I explained to the CEO of Sega, Irimajiri, a really great man. He was the former CEO of Honda USA, went back to Sega to run Sega, went back to Japan to run Sega. And I explained to him that, and I was, 33 years old. When I was 33 years old, I still had acne. And I got this Chinese kid, I was super skinny. And he was already kind of elder. And I went to him and I said, listen, I've got some bad news for you. And first, the technology that we promised you doesn't work. And second, we shouldn't finish your contract because we'd waste all your money and you would have something that doesn't work. And I recommend you find another partner to build your game console.
Whoa.
And so I'm terribly sorry that we've set you back in your product roadmap. And third, even though I'm asking you to let me out of the contract, I still need the money.
어.
Because if you didn't give me the money, we'd vaporize overnight. And so I explained it to him humbly, honestly, gave him the background, explained to him why the technology doesn't work, why we thought it was going to work, why it doesn't work. And I asked him to convert the last $5 million that they were going to complete the contract to give us that money as an investment instead. And he said, but it's very likely your company will go out of business, even with my investment. And it was completely true. Back then, 1995, $5 million was a lot of money. It's a lot of money today. $5 million was a lot of money. And here's a pile of competitors doing it right. What are the chances that giving NVIDIA $5 million, that we would develop the right strategy, that he would get a return on that $5 million or even get it back? 0%. You do the math, it's 0%. If I were sitting there right there, I would have done it. $5 million was a mountain of money to Sega at the time. And so I told him that if you invested that $5 million in us, it is most likely to be lost. But if you didn't invest that money, we'd be out of business and we would have no chance. And I told him that I don't even know exactly what I said in the end, but I told him that I would understand if he decided not to, but it would make the world to me if he did.
Hey, Canada, the holidays are in full swing around. Hold my.
He went off and thought about it for a couple of days and came back and said, we'll do it.
Wow.
It
Did you have a
reminds you-
strategy as to how to correct what it was doing wrong? Did you explain that to him?
Oh man, wait until I tell you the rest of it. It's scary, even scarier.
Oh no.
And so what he decided was Jensen was a young man he liked. That's it.
Wow.
To this day,
That's nuts. Boy, but the world owes that guy,
no doubt.
right? Like what?
Well, he celebrated today in Japan. And if he would have kept that the investment, I think it'd be worth probably about $1 trillion today. I know. But the moment we went public, they sold it. They goes, wow, that's a miracle. So they sold it. Yeah, they sold it at NVIDIA valuation about 300 million. That's our IPO valuation, 300 million.
Wow.
And so anyhow, I was incredibly grateful. And then now we had to figure out what to do, because we still were doing the wrong strategy, wrong technology. So unfortunately, we had to lay off most of the company. We shrunk the company all back. All the people working on the game console, we had to shrink it all back. And then somebody told me that, but Jensen, we've never built it this way before. We've never built it the right way before. We've only known how to build it the wrong way. And so nobody in the company knew how to build this supercomputing image generator 3D graphics thing that Silicon Graphics did. And so I said, okay, how hard can it be? You got all these 30 companies, 50 companies doing it. How hard can it be? And so, luckily, there was a textbook written by the company Silicon Graphics. And so I went down to the store. I had $200 in my pocket, and I bought 3 textbooks, the only 3 they had, $60 a piece. I bought the 3 textbooks. I brought it back and I gave one to each one of the architects, and I said, read that and let's go save the company. And so they read this textbook, learned from the giant at the time, Silicon Graphics, about how to do 3D graphics. But the thing that was amazing, and what makes NVIDIA special today, is that the people that are there are able to start from first principles, learn best known art, but re-implement it in a way that's never been done before. And so when we reimagined the technology of 3D graphics, we reimagined it in a way that manifests today, the modern 3D graphics. We really invented modern 3D graphics, but we learned from previous known arts, and we implemented fundamentally differently.
What did you do that changed it?
Well, ultimately, the simple answer is that the way Silicon Graphics works, the geometry engine is a bunch of software running on processors. We took that and eliminated all the generality, the general purposeness of it, and we reduced it down into the most essential part of 3D graphics. And we hard-coded it into the chip. And so instead of something general purpose, we hard-coded it very specifically into just the limited applications, limited functionality necessary for video games. And that capability, and because we reinvented a whole bunch of stuff, it supercharged the capability of that one little chip. And our one little chip was generating images as fast as a $1 million image generator. That was the big breakthrough. We took $1 million thing and we put it into the graphics card that you now put into your gaming PC. And that was our big invention. And of course the question is how do you compete against these 30 other companies doing what they were doing? And there we did several things. One, instead of building a 3D graphics chip for every 3D graphics application, we decided to build a 3D graphics chip for one application. We bet the farm on video games. The needs of video games are very different than the needs for CAD, needs for flight simulators. They're related but not the same. And so we narrowly focused our problem statement so I could reject all of the other complexities, and we shrunk it down into this one little focus, and then we supercharged them for gamers. And the second thing that we did was we created a whole ecosystem of working with game developers and getting their games ported and adapted to our silicon, so that we could turn essentially what is a technology business into a platform business, into a game platform business. So GeForce is really, today it's also the most advanced 3D graphics technology in the world. But a long time ago, GeForce is really the game console inside your PC. It's, it runs Windows, it runs Excel, it runs PowerPoint, of course, those are easy things. But its fundamental purpose was simply to turn your PC into a game console. So we were the first technology company to build all of this incredible technology in service of one audience, gamers. Now, of course, in 1993, the gaming industry didn't exist. But by the time that John Carmack came along, and the Doom phenomenon happened, and then Quake came out, as you know, that entire community, boom, took off.
Do you know where the name Doom came from? It came from this scene. There's a scene in the movie The Color of Money where Tom Cruise, who's this elite pool player, shows up at this pool hall, and this local hustler says, "What do you got in the case?" And he opens up this case. He has a special pool cue. He goes, "In here?" And he opens it up. He goes, "Doom." And that's where it came
Is
from.
that
'Cause-
right?
Yeah, because Carmack said that's what they wanted to do to the gaming industry.
Doom.
That when Doom came out, it would just be everybody be like, "Oh, we're fucked.
Oh wow.
This is Doom."
That's awesome.
Isn't that amazing?
That's amazing,
Because it's
yeah.
the perfect name for the game.
Yeah.
And
yeah.
the name came out of that scene in that movie.
That's right. Well, and then of course, Tim Sweeney and Epic Games and the 3D gaming genre took off.
Yes.
And so, if you just kind of, in the beginning was no gaming industry. We had no choice but to focus the company on one thing. That one thing.
It's a really incredible origin story. It's amazing. Like, you must be like, look
Started
back.
with a disaster is
That
what.
$5 million, that pivot with that conversation with that gentleman, if he did not agree to that, if he did not like you, what would the world look like today? That's crazy.
Oh wait, then our entire life hung on another gentleman. And so now, here we are. We built. So before GeForce was Riva 128. Riva 128 saved the company. It revolutionized computer graphics. The performance, cost-performance ratio of 3D graphics for gaming was off the charts amazing. And we're getting ready to ship it. We're building it, but so as you know, $5 million doesn't last long, and so every single month, we were drawing down. You have to build it, prototype it. You have to design it, prototype it, get the silicon back, which costs a lot of money. Test it with software. Because without the software testing the chip, you don't know the chip works. And then you're going to find a bug, probably. Because every time you test something, you find bugs. Which means you have to tape it out again. Which is more time, more money. And so we did the math. There was no chance somebody was going to survive it. We didn't have that much time to tape out a chip, send it to a foundry, TSMC, get the silicon back, test it, send it back out again. There was no shot, no hope. And so the math, the spreadsheet doesn't allow us to do that. And so I heard about this company, and this company built this machine. And this machine is an emulator. You could take your design, all of the software that describes the chip, and you could put it into this machine, and this machine will pretend it's our chip. So I don't have to send it to the fab, wait until the fab sends it back, test. I could have this machine pretend it's our chip, and I could put all of the software on top of this machine called an emulator, and test all of the software on this pretend chip, and I could fix it all before I send it to the fab. And if I could do that, when I send it to the fab, it should work. Nobody knows, but it should work. And so we came to the conclusion that let's take half of the money we had left in the bank. At the time, it was about $1 million. Take half of that money and go buy this machine. So instead of keeping the money to stay alive, I took half of the money to go buy this machine. Well, I called this guy up. The company's called ICOS. Called this company up and I said, hey, listen, I heard about this machine. I'd like to buy one. And they go, oh, that's terrific, but we're out of business. I said, what? You're out of business? He goes, yeah, we had no customers. And I said, wait, hang on a second, so you never made the machine? They go, no, we made the machine. We have one in inventory if you want it, but we're out of business. So I bought one out of inventory. Okay. After I bought it, they went out of business.
Wow.
I bought it out of inventory. And on this machine, we put NVIDIA's chip into it, and we tested all of the software on top. And at this point, we were on fumes. But we convinced ourselves that chip is going to be great. And so I had to call some other chip. So I called TSMC. And I told TSMC, listen, TSMC is the world's largest foundry today. At the time, they were just a few $100 million large. Tiny little company. And I explained to them what we were doing. And I explained to them, I told them I had a lot of customers. I had one, Diamond Multimedia. Probably one of the companies you bought the graphics card from back in the old days. And I said, we have a lot of customers, and the band's really great. And we're going to tape out a chip to you. And I like to go directly to production. Because I know it works. And they said, nobody has ever done that before. Nobody has ever taped out a chip that worked the first time. And nobody starts out production without looking at it. But I knew that if I did start the production, I'd be out of business anyways. And if I could start the production, I might have a chance. And so TSMC decided to support me. And this gentleman is named Morris Chang. Morris Chang is the father of the foundry industry, the founder of TSMC. Really great man. He decided to support our company. I explained to them everything. He decided to support us, frankly, probably because they didn't have that many other customers anyhow. But they were grateful, and I was immensely grateful. And as we were starting the production, Morris flew to the United States, and he didn't so many words ask me so, but he asked me a whole lot of questions that was trying to tease out, do I have any money? But he didn't directly ask me that, And so the truth is that we didn't have all the money, but we had a strong PO from the customer. And if it didn't work, some wafers would have been lost. And I'm not exactly sure what would have happened, but we would have come short. It would have been rough. But they supported us with all of that risk involved. We launched this chip. Turns out to have been completely revolutionary. Knocked the ball out of the park. We became the fastest growing technology company in history to go from 0 to $1 billion.
It's so wild that you didn't test the chip.
I know. Oh,
Right
we
into
tested
production.
afterwards. Yeah, we tested afterwards.
Tested it afterwards.
Went into production already.
But by the way, that methodology that we developed to save the company is used throughout the world today.
That's amazing.
Yeah, we changed the whole world's methodology of designing chips, the whole world's rhythm of designing chips. We changed everything.
How well did you sleep those days? It must have been so much stress.
What is that feeling where the world just kind of feels like it's flying? You have this. What do you call that feeling? You can't stop the feeling that everything's moving super fast, and you're laying in bed, and the world just feels like you feel deeply anxious, completely out of control. I've felt that probably a couple of times in my life. It's during that time.
Wow.
Yeah, it was incredible.
What an incredible success story.
But I learned a lot. I learned several things. I learned how to develop strategies. I learned how to, and when our company learned how to develop strategies. What are winning strategies? so that exact same skill is how we created the modern AI market. It's exactly the same. Yeah, it's exactly the same skill, exactly the same blueprint. And we learned how to deal with crisis, how to stay calm, how to think through things systematically. We learned how to remove all waste in the company and work from first principles and doing only the things that are essential. Everything else is waste because we have no money for it. To live on fumes at all times. And the feeling, no different than the feeling I had this morning when I woke up, that you're going to be out of business soon. That you're, the phrase 30 days from going out of business, I've used for 33 years.
You still feel?
Oh yeah.
Really?
Every morning.
But you guys are one of the biggest companies on planet Earth.
But the feeling doesn't change.
Wow.
The sense of vulnerability, the sense of uncertainty, the sense of insecurity, it doesn't leave you.
That's crazy.
We had nothing. We were
And you
dealing
still
with
feel
giant.
that?
Oh yeah. Every day, every moment.
Do you think that fuels you? Is that part of the reason why the company's so successful? That you have that hungry mentality? That you never rest. You're never sitting on your laurels. You're always on the edge.
I have a greater drive from not wanting to fail than the drive of wanting to succeed.
Isn't that like
I think
success coaches would tell you that's completely the
Joe,
wrong
I think
psychology?
the world has just heard me say that out loud for the first time, but it's true.
Well, that's so
The
fascinating.
fear of failure drives me more than the greed or whatever it is.
Well, ultimately, that's probably a more healthy approach. Now that I'm thinking about it, because like the fear.
I'm not ambitious, for example. I just want to stay alive, Joe. I want the company to thrive. I want us to make an impact.
That's interesting.
Yeah.
Well, maybe that's why you're so humble. Maybe that's what keeps you grounded. Because with the kind of spectacular success that the company's achieved, it would be easy to get a big head.
No.
Right? But isn't
Yeah.
that interesting? It's
Yeah.
like if you were the guy that your main focus is just success, you probably would go, well, made it, nailed it, I'm the man.
Drop the mic.
Instead, you wake up, you're like, God, we can't fuck this up.
No, exactly. Every morning. No, every moment.
That's crazy.
Before I go to bed.
Well, listen, if I was a major investor in your company, that's who I'd want running it. I'd want a guy who's
that's
like
why I work.
terrified of... Yeah.
That's what I work. That's why I work 7 days a week. Every moment I'm awake.
You work every moment.
Every
you're awake.
moment I'm awake.
Wow.
I'm thinking about solving a problem. I'm thinking about.
How long can you keep this up?
I don't know, but so could be next week.
Sounds exhausting.
It is exhausting.
It sounds completely exhausting.
Always in a state of anxiety.
Wow.
Yeah, always in a state of anxiety.
Well, kudos to you for admitting that. I think that's important for a lot of people to hear because, there's probably some young people out there that are in a similar position to where you were when you were starting out that just feel like, oh, those people that have made it, they're just smarter than me and they had more opportunities than me and it's just like it was handed to them or they're just in the right place at the right time. And
Joe, I just described to you somebody who didn't know what was going on. Actually did it wrong. Yeah, and the ultimate diving catch like 2 or 3 times.
Crazy.
Yeah.
The ultimate diving catch is the perfect way to put it. It's just like the edge of your glove.
It probably bounced off of somebody's helmet and landed at the edge.
God, that's incredible. It's incredible, but it's really cool that you have this perspective, that you look at it that way. Because, a lot of people that have delusions of grandeur, or they have,
and
inflated.
their rewriting of history oftentimes had them somehow extraordinarily smart, and they were geniuses, and they knew all along, and they were spot on. The business plan was exactly they destroyed the competition, and and they emerged victorious.
Meanwhile, you're like, I'm scared every day. It's so funny. Oh my God, that's amazing.
It's so true, though.
It's amazing.
It's so true.
It's
Yeah.
amazing.
Well, but I think there's nothing inconsistent with being a leader and being vulnerable. The company doesn't need me to be a genius, right all along, right all the time, absolutely certain about what I'm trying to do and what I'm doing. The company doesn't need that. The company wants me to succeed. The thing that, and we started out today talking about President Trump, and I was about to say something. And listen, he is my president. He is our president. We should all, and we're talking about just because it's President Trump, we all want him to be wrong. I think the United States, we all have to realize he is our president. We want him to succeed because
No matter who's president, we
That's
should have
right.
that attitude. Yeah.
That's right.
Yeah.
We want him to succeed. We need to help him succeed because it helps everybody, all of us succeed. And I'm lucky that I work in a company where I have 40,000 people who wants me to succeed. They want me to succeed, and I can tell. And they're all every single day to help me overcome these challenges, trying to realize what I described to be our strategy, doing their best. And if it's somehow wrong or not perfectly right, to tell me so that we could pivot. And the more vulnerable we are as a leader, the more able other people are able to tell you, that Jensen, that's not exactly the right word.
Right.
Have you considered this information? And the more vulnerable we are, the more able we're actually able to pivot. If we put ourselves into this superhuman capability, then it's hard for us to pivot strategy.
Right.
Because we were supposed to be right all along. And so if you're always right, how can you possibly pivot? Because pivoting requires you to be wrong. And so I've got no trouble with being wrong. I just have to make sure that I stay alert, that I reason about things from first principles all the time. Always break things down to first principles, understand why it's happening. Reassess continuously. The reassessing continuously is kind of partly what causes continuous anxiety. Because you're asking yourself, were you wrong yesterday? Are you still right? Is this the same? Has that changed? Has that condition? Is that worse than you thought?
Because that mindset is perfect for your business, though. Because this business is ever changing.
All the time.
And
I've got
there's-
competition going from every direction.
So much of it is kind of up in the air.
And you have to invent a future where 100 variables are included. And there's no way you can be right on all of them. And so you have to surf.
Wow.
You have to surf.
That's a good way to put it. You
Yeah.
have to surf.
Yeah.
You're surfing waves of technology and innovation.
That's right. You can't predict the waves. You got to deal with the ones you have.
Wow.
But skill matters. And I've been doing this for 30. I'm the longest running tech CEO in the world.
Is that true?
Yeah.
Congratulations. That's
Yeah.
amazing.
People ask me how. Is one, don't get fired. I'll stop it short in a heartbeat. And then two, don't get bored. Yeah.
Well, how do you maintain your enthusiasm?
The honest truth is not always enthusiasm. Sometimes it's enthusiasm. Sometimes it's just good old-fashioned fear. And then sometimes, a healthy dose of frustration. It's
Whatever keeps you moving.
yeah, just all the emotions. I think, CEOs, we have all the emotions, right? Yeah. And so probably jacked up to the maximum because you're kind of feeling it on behalf of the whole company. I'm feeling it on behalf of everybody at the same time. And it kind of, it encapsulates into somebody. And so I have to be mindful of the past, I have to be mindful of the present, I'm going to be mindful of the future. And, it can't, it's not without emotion. It's not just a job. Let's just put it that way.
It doesn't seem like it at all. I would imagine one of the more difficult aspects of your job currently, now that the company is massively successful, is anticipating where technology is headed and where the applications are going to be.
Yeah.
So how do you try to map that out?
Yeah, there's a whole bunch of ways, and it takes a whole bunch of things. But let me just start. You have to be surrounded by amazing people, and NVIDIA is now. And if you look at the large tech companies in the world today, most of them have a business in advertising or social media or content distribution, and at the core of it is really fundamental computer science. And so the company's business is not computers. The company's business is not technology. Technology drives the company. NVIDIA is the only company in the world that's large whose only business is technology. We only build tech. We don't advertise. The only way that we make money is to create amazing technology and sell it. And so to be NVIDIA today, the number one thing is you're surrounded by the finest computer scientists in the world. And that's my gift. My gift is that we've created a company's culture, a condition by which the world's greatest computer scientists want to be part of it. Because they get to do their life's work and create the next thing. Because that's what they want to do. Because maybe they don't want to be in service of another business. They want to be in service of the technology itself. And we're the largest form of its kind in the history of the world.
Wow.
I know, it's pretty amazing.
Wow.
And so one, we have got a great condition, we have a great culture, we have great people. And then now the question is, how do you systematically be able to see the future, stay alert of it, and reduce the likelihood of missing something or being wrong. And so there's a lot of different ways you could do that. For example, we have great partnerships. We have fundamental research. We have a great research lab, one of the largest industrial research labs in the world today. And we partner with a whole bunch of universities and other scientists. We do a lot of open collaboration. And so I'm constantly working with researchers outside the company. We have the benefit of having amazing customers. And so I have the benefit of working with Elon and others in the industry. And we have the benefit of being the only pure play technology company that can serve consumer internet, industrial manufacturing, scientific computing, healthcare, financial services. All the industries that we're in, they're all signals to me. And so they all have mathematicians and scientists. And so because I have the benefit now of a radar system that is the most broad of any company in the world, working across every single industry, from agriculture to energy to video games. And so the ability for us to have this vantage point, one, doing fundamental research ourselves, and then two, working with all the great researchers, working with all the great industries, the feedback system is incredible. And then finally, you just have to have a culture of staying super alert. There's no easy way of being alert except for paying attention. I haven't found a single way of being able to stay alert without paying attention. And so, I probably read several thousand emails a day.
How? How do you have the time for that?
I wake up early. This morning I was up at 4 o'clock.
How much do you sleep?
6-7 hours. Yeah,
And then you're up at 4, read
Yeah.
emails for a few hours before you get going.
that's right. Yeah,
Wow. Every day.
every single day, not one day missed, including Thanksgiving, Christmas.
Do you ever take a vacation?
Yeah, but they're, my definition of a vacation is when I'm with my family. And so, if I'm with my family, I'm very happy. I don't care where we are.
And you don't work then? Or do you work a little?
No, I work a lot.
Even when you, if you go on a trip somewhere,
Oh, sure.
you're still working.
Oh, sure.
Wow. Every day.
Every day.
Oh,
But my kids work every day.
You make me tired just saying this.
My kids work every day. Both of my kids work every day. They work every day.
Wow.
Yeah, I'm very lucky.
Wow.
Yeah, it's brutal now because, it's just me working every day. Now we have 3 people working every day, and they want to work with me every day, and so it's a lot of work.
Well, you've obviously imparted that ethic into them.
They
that
work
ethic.
incredibly hard.
I mean, there's
Unbelievable.
no,
But my parents work incredibly hard.
Hey, Canada, the holidays are in full reround. You ever?
Yeah, I was born with the work gene, the suffering gene.
Well, listen, man, it has paid off. What a crazy story. It's really an amazing origin story. It really is. I mean, it has to be kind of surreal to be in the position that you're in now when you look back at how many times that it could have fallen apart. Humble beginnings.
But Joe, it's a great country. I'm an immigrant. My parents sent my older brother and I here first. We're in Thailand. I was born in Taiwan, but my dad had a job in Thailand. He was a chemical and instrumentation engineer, incredible engineer. And his job was to go start an oil refinery. And so we moved to Thailand, lived in Bangkok. And in 1973, 1974 time frame, how Thailand every so often they would just have a coup. The military would have an uprising. And all of a sudden one day there were tanks and soldiers in the streets. And my parents thought, probably isn't safe for the kids to be here. And so they contacted my uncle. My uncle lives in Tacoma, Washington. And we had never met him. And my parents sent us to him.
How old were you?
I was about to turn 9. And my older brother almost turned 11. And so the 2 of us came to the United States. And we stayed with our uncle for a little bit while he looked for a school for us. And my parents didn't have very much money. And they never had been to the United States. My father was, and I'll tell you that story in a second. And so my uncle found a school that would accept foreign students and affordable enough for my parents. And that school turned out to have been in Oneida, Kentucky, Clark County, Kentucky, the epicenter of the opioid crisis today. Coal country. Clark County, Kentucky was the poorest county in America when I showed up. It is the poorest county in America today. And so we went to the school. It's a great school. Oneida Baptist Institute. In a town of a few hundred. I think it was 600 at the time that we showed up. No traffic light. And I think it's 600 today. It's kind of amazing feat, actually. The ability to hold your population for when it's 600 people is quite a quite a magical thing. However they did it. And so the school had a mission of being an open school for any children who'd like to come. And what that basically means is that if you're a troubled student, if you have a troubled family, if you're, whatever your background, you're welcome to come to Oneida Baptist Institute, including kids from international who would like to stay there.
Did you speak English at the time?
Okay, yeah. Okay, yeah. And so we showed up, and my first thought was, gosh, there are a lot of cigarette butts on the ground. 100% of the kids smoked. So right away, this is not a normal school.
9-year-olds?
No, I was the youngest kid.
Okay. 11-year-olds.
My roommate was 17 years old.
Wow.
Yeah, he just turned 17. And he was jacked. that night we got, and the second thing I noticed when you walk into your dorm room is that there are no drawers and no closet doors, just like a prison. And there are no locks, so that people can check up on you. And so I go into my room, and he's 17, and we, get ready for bed, and he had all this tape all over his body, and turned out he was in a knife fight, and he's been stabbed all over his body, and these were just fresh wounds. And the other kids were hurt much worse. And so he was my roommate, the toughest kid in school, and I was the youngest kid in school. It was a junior high, but they took me anyways, because if I walked about a mile across the Kentucky River, the Swing Bridge, the other side is a middle school that I could go to, and then I can go to that school, and I come back, and then I stay in the dorm. And so basically Oneida Baptist Institute was my dorm when I went to this other school. My older brother went to the junior high, and so we were there for a couple of years. Every kid had chores. My older brother's chore was to work in the tobacco farm. So they raised tobacco so that they could raise some extra money for the school, kind of like a penitentiary.
Wow.
And my job was just to clean the dorm. And so I was 9 years old. I was cleaning toilets and for a dorm of 100 boys. I cleaned more bathrooms than anybody. And I just wish that everybody was a little bit more careful. But anyways, I was the youngest kid in school. My memories of it was really good, but it was it was a tough town.
Sounds like.
Yeah, town kids, everybody had knives. Everybody had knives. Everybody smoked. Everybody had a Zippo lighter. I smoked for a week.
Did you?
Oh yeah, sure.
How old were you?
I was 9, yeah.
Well, you're 9. You're 9, you tried smoking.
Yeah, I got myself a pack of cigarettes, everybody else did.
Did you get sick?
No, I got used to it. And I learned how to blow smoke rings, and breathe out of my nose, take it in out of my head through my nose. Those are all the different things that you learn. Yeah.
At 9?
Yeah.
Wow, you just did it to fit in, or look
Yeah,
cool?
because everybody else did it.
Right.
Yeah. And then I did it for a couple of weeks, I guess, and I just rather I had a quarter, I had a quarter a month or something like that. I just rather buy popsicles and fudgesicles with it. I was 9,
Right.
I chose the better path.
Wow.
That was our school, and then my parents came to the United States 2 years later, and we met them in Tacoma, Washington.
That's wild.
It was a really crazy experience.
What a strange, formative experience.
Yeah, tough kids.
Thailand to one of the poorest places in America, or if not the poorest, as a 9-year-old.
Yeah, it was my first
By yourself,
experience. Yeah,
with your brother. Wow.
No, I used to remember, and what breaks my heart, probably the only thing that really breaks my heart about that experience was, so we didn't have enough money to make, international phone calls every week, and so my parents gave us this tape deck, this Iowa tape deck, and a tape, and so every month we would sit in front of that tape deck, and my older brother Jeff and I, the two of us would just tell them what we did the whole month.
Wow.
And we would send that tape by mail. Now my parents would take that tape and record back on top of it and send it back to us.
Wow.
Could you imagine if for 2 years, that tape still existed, of these two kids just describing their first experience with the United States? Like, I remember telling my parents that I joined the swim team, and my roommate was really buff, and so every day we spent a lot of time in the gym, and so every night 100 push-ups, 100 sit-ups, every day in the gym. So I was 9 years old. I was pretty buff,
뭐지?
and I'm pretty fit. And
OBS 뭐야?
and so I joined the soccer team. I joined the swim team because if you join the team, they take you to meets, and then afterwards you get to go to a nice restaurant. And that nice restaurant was McDonald's. And I recorded this thing. I said, Mom and Dad, we went to the most amazing restaurant today. This whole place is lit up. It's like the future. And food
다리까지
comes in a
그리고
box.
도망가야지.
And the food is incredible. The hamburger is incredible. It's McDonald's. But anyhow, wouldn't it be amazing?
Oh my God.
2 years.
Recording?
Yeah, 2 years. Yeah.
What a crazy connection to your parents too. Just sending a tape and them sending you one back. It's the only way of communicating for 2 years.
Yeah.
Wow.
Yeah. No, my parents are incredible. Actually, they grew up really poor, and when they came to the United States, they had almost no money. Probably one of the most impactful memories I have is they came in. We were staying in a apartment complex. And they had just rent back in the, I guess people still do rent a bunch of furniture. And we were messing around, and we bumped into the coffee table and we crushed it. It was made out of particle wood. We crushed it. And I just still remember the look on my mom's face, because they didn't have any money and she didn't know how she was going to pay it back. But anyhow, that kind of tells you how hard it was for them to come here. But they left everything behind, and all they had was their suitcase and the money that they had in their pocket, and they came to the United States.
How old were they at
Pursued
the
the
time?
American dream. They were in their 40s.
Wow.
Yeah, late 30s. Pursued the American dream. This is the American dream. I'm the first generation of the American dream.
Wow.
Yeah, it's hard not to love this country. It's hard not to be romantic about this country.
That is a romantic story. That's an amazing story.
Yeah, and my dad found his job literally in the newspaper. The ads, and he calls people, got a job.
What did he do?
He was a consulting engineer in a consulting firm, and they helped people build oil refineries, paper mills, and fabs, and that's what he did. He's really good at factory design, instrumentation engineer, and so he's brilliant at that. And so he did that, and my mom worked as a maid, and they found a way to raise us.
Wow. That's an incredible story, Jensen. It really is. Everything, all of it, from your childhood to the perils of NVIDIA almost falling. It's really incredible, man.
It's a great story. Yeah, I've lived a great life.
You really have, and it's a great story for other people to hear too. It really is.
You don't have to go to Ivy League schools to succeed. This country creates opportunities and has opportunities for all of us. You do have to strive. You have to claw your way here. Yeah.
But if you put in the work, you can succeed.
Nobody works
With a lot
harder.
of luck and a lot of good decision making.
And the good graces of others.
Yes. That's really important.
Yeah, you and I spoke about two people who are very dear to me, but the list goes on. The people at NVIDIA who have helped me, many friends that are on the board, the decisions, them giving me the opportunity. Like when we were inventing this new computing approach, I tanked our stock price because we added this thing called CUDA to the chip. We had this big idea. We added this thing called CUDA to the chip, but nobody paid for it. But our cost doubled. And so we had this graphics chip company, and we invented GPUs. We invented programmable shaders. We invented everything modern computer graphics. We invented real-time ray tracing. That's why it went from GTX to RTX. We invented all this stuff, but every time we invented something, the market doesn't know how to appreciate it, but the cost went way up. And in the case of CUDA that enabled AI, the cost increased a lot. But we really believed it, you know. And so, if you believe in that future, and you don't do anything about it, you're going to regret it for your life. And so I always tell the team, do we believe this or not? And if you believe it, and it's grounded on first principles, not random, hearsay, and we believe it, we owe it to ourselves to go pursue it. If we're the right people to go do it, if it's really, really hard to do, it's worth doing, and we believe it, let's go pursue it. Well, we pursued it. We launched the product. Nobody knew. It was exactly like when I launched DGX1, and the entire audience was like complete silence. When I launched CUDA, the audience was complete silence. No customer wanted it. Nobody asked for it. Nobody understood it. NVIDIA was a public company.
What year was this?
This is let's say 2006, 20 years ago. 2005.
Wow.
Our stock prices went. I think our valuation went down to like $2 or $3 billion from about 12 or something like that. I crushed it in a very bad way. Yeah.
What is it now, though?
It's higher.
Very humble of you.
It's higher, but it changed the world.
Yeah.
That invention changed the world.
It's an incredible story, Jensen. It really is. Thank you.
Like your story, it's incredible.
My story's not as incredible. My story's more weird. You know? It's much more fortuitous and weird.
Okay, what are the three most important milestones that led to here?
That's a good question.
What was step one?
I think step one was seeing other people do it. Step one was in the initial days of podcasting, like in 2009 when I started. Podcasting had only been around for a couple of years. The first was Adam Curry, my good friend, who was the podfather. He invented podcasting. And then, I remember Adam Carolla had a show because he had a radio show. His radio show got canceled. And so he decided to just do the same show but do it on the internet. And that was pretty revolutionary. Nobody was doing that. And then there was the experience that I had doing different morning radio shows, like Opie and Anthony in particular, because it was fun. And we would just get together with a bunch of comedians. I'd be on the show with like 3 or 4 other guys that I knew. And it was always just, looked forward to it. It was just such a good time. And I said, God, I miss doing that. It's so fun to do that. I wish I could do something like that. And then I saw Tom Green set up. Tom Green had a setup in his house. And he essentially turned his entire house into a television studio. And he did an internet show from his living room. He had servers in his house and cables everywhere. He had to step over cables. This is like 2007. I'm like, Tom, this is nuts. Like, this is... And I'm like, you got to figure out a way to make money from this. Like,
I wish
this
everybody on the internet could see your setup. It's nuts. I just want to let you guys know that. It's not just this.
Yeah. So that was the beginning of it. Was just seeing other people do it, and then saying, all right, let's just try it. And then so the beginning days, we just did it on a laptop. Had a laptop with a webcam and just messed around. Had a bunch of comedians come in. We would just talk and joke around. And I did it like once a week. And then I started doing it twice a week. And then all of a sudden I was doing it for a year. And then I was doing it for 2 years. Then it's like, oh, it's starting to get a lot of viewers, a lot of listeners, and then I just kept doing it. That's all it is. I just kept doing it because I enjoyed doing it.
Was there any setback?
No, there's never really a setback.
Really?
No.
It
No.
must have been. Or
It's not the same kind of story.
You're just resilient. Or you're just tough.
No. It wasn't tough or hard. It was just interesting. So I just the
You were
whole-
never once punched in the face.
No, not in the show. No, not really. Not doing the show.
You never did something that big blowback.
Nope. Not really. No, it all just kept growing. It kept growing, and the thing stayed the same from the beginning to now. And the thing is, I enjoy talking to people. I've always enjoyed talking to interesting.
I could even
people.
tell just when we walked in, the way you interacted with everybody, not just me. Yeah, that's cool.
People
That's
are cool.
Yeah, that's cool.
You know, it's an amazing gift to be able to have so many conversations with so many interesting people, because it changes the way you see the world, because you see the world through so many different people's eyes, and you have so many different people have different perspectives and different opinions and different philosophies and different life stories, and you know, it's an incredibly enriching and educating experience having so many conversations with so many amazing people. And that's all I started doing, and that's all I do now. Even now, when I book the show, I do it on my phone, and I basically go through this giant list of emails of all the people that want to be on the show or that request to be on the show. And then I factor in another list that I have of people that I would like to get on the show that I'm interested in. And I just map it out. And that's it. And I go, ooh, I'd like to talk to him.
If it wasn't because of President Trump, I wouldn't have been bumped up on that list.
No, I wanted to talk to you already. I just think, you know, what you're doing is very fascinating. I mean, how would I not want to talk to you? And then today, it proved to be absolutely the right decision.
Well, you know, listen, it's strange to be an immigrant one day, going to Oneida Baptist Institute with the students that were there, and then here, NVIDIA's one of the most consequential companies in the history of companies. It is a crazy story.
It has to be
Yeah,
strange for
that
you.
journey is and it's very humbling, and I'm very grateful.
It's pretty amazing.
Surrounded by amazing people.
You're very fortunate, and you seem very happy, and you seem like you're 100% on the right path in this life.
You know, everybody says you must love your job. Not every day.
That's
You know what I'm saying?
part of
Yeah.
the beauty of everything.
Yeah.
Is that there's ups and downs.
That's
It's like,
right.
It's never just like this giant dopamine high.
We leave this impression. Here's an impression I don't think is healthy. People who are successful leave the impression of it that our job gives us great joy. I think largely it does. That our jobs, we're passionate about our work. And that passion relates to, it's just so much fun. I think it largely is. But it distracts from, in fact, a lot of success comes from really, really hard work.
Yes.
There's long periods of suffering and loneliness and uncertainty and fear and embarrassment and humiliation. All of the feelings that we most not love. That creating something from the ground up, and Elon will tell you something similar. Very difficult to invent something new.
Yeah.
And people don't believe you all the time. You're humiliated often, disbelieved most of the time. And so people forget that part of success. And I don't think it's healthy. I think it's good that we pass that forward and let people know that it's just part of the journey.
Yes. And
The
then
suffering is part of the journey.
you will appreciate it so much. These horrible feelings that you have when things are not going so well, you will appreciate it so much more when they do go well.
Deeply grateful.
Yeah.
Yeah, deep pride, incredible pride, incredible gratefulness, and surely incredible memories.
Absolutely. Jensen, thank you so much for being here. Those are really.
안녕하세요. 좋은 아침입니다. 도망가려고 했는데 오셨네요? 응? 귀엽죠? 고양이 그 유튜브 쇼츠 보다가 스크린 캡처해가지고 저장해놨어요. 요즘은 유튜브 쇼츠밖에 안 봐요. 이제는 긴 영상 못 보겠어요. 방제 보고 달려왔죠? 도망치려고 해서. 들켰다. 언제 일어나셨어요? 설마 새벽까지 작업하셨나요? 중독인가요? 도망가는 거요? 어떻게 하셨지? 중독인 거? 3시에 일어나셨어요? 헐. 헐. 오케이, 오케이. 오늘 1차분 넘겨야 하는데 하나도 못해서 자다 깼죠. 저런. 힘내세요. 이거자 콕콕콕. 좀 그려야 하는데 타블렛 보면 심장이 뛰면서 머리 아파서 축구 보며 좀 쉬고 있습니다. 축구 실제로 하시나요? 플레이 하시나요? 근데 겨울에는 축구 안 되겠다. 그죠? 저는 자전거와 탁구만. 저 예전에 고등학생 때 친구네 집에 놀러 가서 탁구 해봤는데 탁구 엄청 어렵더만. 생각보다 너무 어려웠어요. 다 옛날 얘기지만. 배드민턴은 좀 할 줄 아는데 탁구는 너무 어려워. 옛날이라니. 다 옛날 얘기죠. 옛날이요. 옛날이요. 에? 탁구는 언제 치세요, 그러면? 시간이 있어요? 주말에 하시나? 자전거와 탁구. 이탈리아 콜라 마시고 싶다. 이탈리아 콜라랑 멕시코 콜라. 미국 콜라는 너무 맛이 없어. 콜라 콜라. 한국 콜라는 어때요? 한국 코카콜라 맛있나요? 요즘 콜라는 맛이 없어요. 어떻게 된 거야? 어? 왜 이렇게 맛없어졌어? 옛날에는 맛있었는데. 펩시 제로 라임이 맛있어요? 메모. 펩시 제로 라임. 이 색깔이 아닌데. 저도 닥터페퍼 좋아해요. 저 이제 도망갈래요. 나머지는 다음에 하죠. 누워야겠어요. 가볼게요.